In this video, I'm going to cover how to install a custom blade controller into a Galaxy's Edge lightsaber blade. So here is the fully assembled blade controller. This blade controller is designed to fit Galaxy's Edge lightsaber blades. Some newer Galaxy's Edge lightsabers that come in a set that include a blade, they're screw-in blades. This won't fit those. Those are special blades, single color, designed just for that hilt that they're packaged with. This is for the blades that can produce multiple colors. The ones that you get with a Savvy's Workshop lightsaber hilt, which are 31 inches long, or the 36 or 26 inch blades that you can buy at docks and on Shop Disney. To install one of these blade controllers, you need to open up your lightsaber blade and desolder the old lightsaber blade controller, and then solder this in its place and connect all the wires up as needed, and maybe install some optional switches, which we'll cover later in the video, and you should be good to go. Let's get started. I have here a brand new, never before opened 36-inch lightsaber blade. And there is the new blade. So we need to get into the base of the blade here, and that's easy enough. There are 3 screws here, and we just remove the screws. Put those 3 screws off to the side. Do not lose them. Now this case here, this black piece, splits in half. The first time you remove it, it's probably going to stick a little bit, so just work it back and forth a little bit like that, and it should hopefully pop off like that. There are these little silver pieces, I call them the guides, used to make sure the blade is oriented correctly when you insert it into your hilt. Just remove those. Those are loose. Put them off to the side along with your screws. And we can just pull this out a little ways here. And what we have here is a inner sleeve. This too splits in half. What I usually do is there's a little bit of an opening here on the end where you see these wires coming out. I try to get my finger in there to start separating these 2 halves. Go slowly. There's no point in rushing this. You don't want to break anything. And there we go. There's one half and the other half on the bottom side. Make note, from the bottom side has the post coming up. The top side has the receiving end of that. Put these off to the side for now. You will need them, of course, later. And there is the blade controller. The blade controller and the LEDs are on 2 separate PCBs. You can sort of see that sandwich right there. They're held together by solder joints. We have 7 solder joints here at the end of the blade controller PCB. And we have 2 more on the back in the middle here. And we need to desolder all of that. There are a couple of ways to go about this. If you have that hot air reflow station, that might actually be your best bet, because it allows you to apply heat to the whole area here, get everything warmed up, so in theory the whole board should come apart in one go. But I instead am going to use a regular soldering iron to remove all of this. My approach for removing the blade controller from the LEDs is to first try to remove as much solder from these 2 joints as possible, and then flood all 7 of these connections with solder, so it's just one big blob of solder going across all 7, and heating that blob with my soldering iron so all of these connections here are molten, are loose, and then bend that PCB up a little bit. And if there's a little bit of solder left here, it'll sort of bend at that joint. And once the blade controller PCB has been lifted up a little bit, I can come back in and remove all the excess solder. That will create a gap on this end between these 2 PCBs. Then I can come back over here and reflow the solder on these 2 joints, and that should then free it up. And if that didn't make any sense, don't worry, you'll see it in action in just a moment. So the first thing I want to do is to try and remove as much solder as I can from these 2 joints. Now I would really like this PCB to be laying as flat as possible, but the wires coming up off of it are sort of creating a little gap here. Just to make life a little easier, I'm going to bring in my ceramic tile and let the PCB hang off the edge a little bit. So that way I can keep it flat and apply pressure here without having to worry that I'm going to bend or break the PCB. And I'll just tape this in place just to help give it a chance at not moving around too much while I'm working on it. The very first thing I'm going to do is tin the tip of my iron here. I'm just going to put some solder on the tip. I'm going to wipe it off and probably do that 1 or 2 more times. This is removing the oxidation that's formed since I last used this particular soldering iron tip. Cleaning the surface to provide better heat transfer for the solder when I apply it to the PCB. So I'm going to flood both of these connections with excess solder here. This is going to do a couple of things here. This is going to apply fresh flux that's in the solder to help make the existing solder that's there flow a little bit easier. It's also diluting the solder that's came with the PCB, or came with the blade, I should say. And maybe that particular type of solder isn't easy to work with, so replacing it with solder that I use regularly, that I know is easy to work with, is preferable, at least to me. Now I'm going to take some solder wick here and apply that to the joint, and hopefully the wick sucks up all the solder that's there. My goal here is to try and get rid of as much solder that's between these two PCBs at these joints as possible. If there's a little bit of solder behind, it might make removal of the board a little bit more difficult. And I am applying the wick to both the top and bottom PCBs here, just to help ensure that I get rid of as much. Oh, look at that. You can even see the solder wick has slid underneath there. So I've got a clean surface now, or a broken connection there. That's perfect. That's exactly what I want. If the solder wick wasn't able to get all of the solder on those joints, but I got most of it, a little bit left would be fine. You can bend them without destroying the pads there. But in this case, I have completely separated the top and the bottom there. That actually went really easily for me, which is a first. Don't be surprised if your experience isn't as smooth. I want to flood the 7 connections here with fresh solder. And what's going to happen is at some point the PCB is actually just going to fall away. We're not trying to be pretty here. We're not trying to be anything other than just literally dump a ton of solder. So we just have one big blob connecting all 7 of these. And there we go. The blade controller has come off. That was by far the easiest removal of the stock blade controller I have ever done. And I just want to give you an idea that it's not always going to go perfectly. Alright, so here we go. First step is I'm going to flood these 2 ground joints with solder. Next step is I'm going to come in here with my solder sucker and try to suck up as much of this solder as I can. Give it a few seconds because I got to heat up the ground planes. And we'll just quickly inspect that so you can see what it looks like. And I can still see a little bit of solder there. It looks like there's still a connection there, which is good because now this is going to help me demonstrate the other technique, which is assuming you still have a little bit of solder here. I'm going to flood all of these joints on the top of the blade controller. And then I just, I'll hold here and push down here, and it should lift up a little bit. And this is also why I want to use the tile here. It puts some space between the blade controller and the work surface below, so that way it has room to flip up. Let's get to it. Flood this whole area with solder here. Alright, I'll start pushing. There we go. There we go. So now we have a gap here. Now, enough of a gap was formed there that the solder connections broke, but if the gap that formed there was a bit shorter, and I still had some solder connecting the 2 PCBs together, with that little gap there, I could then come back in, with my iron and maybe my solder sucker and remove the excess solder to clear out that gap so there was no connection on that end. And now I just flip over the PCB here and reflow the solder on those joints, and away it comes. Before we continue with the blade controller, I want to clean up these joints. I'm going to bring back that solder wick that we used earlier. The key with solder wick is to not drag, just push down and then let it come back up. If you drag, what ends up happening is the wick can start to tear away at the solder mask. It can even pull pads off. Pads are basically copper that's been glued down to the PCB, and the heat will loosen that glue, and you can drag the wick and inadvertently pull a pad with it. So just push down with your iron, let it suck up the solder, remove your iron, and move to the next position. If the solder wick gets stuck to a pad, don't be tempted to just yank it off. Just go back and apply your iron some more, and be patient. Maybe you need to keep applying heat for a few seconds longer than you expected. Eventually, it'll come off. I also want to remove the solder from the end connections here. Good. Now the flux that you see, brown stuff that's on that PCB there, that will clean up with some isopropyl alcohol. And you don't need to press down too forcefully here. Just let the IPA do its own thing and dissolve the flux. This cleanup is not entirely necessary, but the flux residue will be sticky, and I'll be handling this PCB when we're putting things back together. I just don't want to end the day with sticky fingers. In case you're curious, the number on the back here, 2239, that's when this LED PCB was manufactured. That would be 2022 in the 39th week. The blade controller also has a similar number. This is 2232. So the 32nd week of 2022 is when this was manufactured. So I'm going to put the LED PCB off to the side for now. We don't need that. I'm going to bring in my vise here to make my life a little bit easier. I would recommend it if you have a vise as well. To remove these wires for the connector, I'm just going to heat up the different joints where the wires are connected to and just sort of gently tug them out of the PCB. Like this. This is the data line way over here. And there, just remove that wire. And we have the red wire, which should be right here. And that comes out just like that. If you find that your iron isn't getting to the joint to make the solder go molten, go ahead and throw in a little extra fresh solder. That will help your iron make connections to the joint. And there we go. There is our blade connector, which we will reuse with our new blade controller. So now, do we solder the connector to the PCB before we then put everything back together? Again, it's your call which order you want to go with. I'll go ahead and solder these together now. We have 3 wires here, white, red, and black. White is the data connection, red is the positive or power connection, and black is the ground connection. Now you saw on the other blade controller, these came in from the bottom. You could come in from the top as well. Either approach is fine. There's no right or wrong here. The tricky part will be, how do you hold this in place while you're soldering? And there's a couple of things you could do. You could not use the vise at all and just, connect one wire here like that and sort of try to balance it as best you can, and then come in with your iron and solder that. You could maybe bring it up here on the vise and try to bend things in such a way that everything stays connected while you make that first solder joint. Just whatever you can find that works for you, go for it. I'd suggest soldering the data line first because there's very low thermal mass there, so it takes but a second to solder. Oops. But there we go. That is soldered. So now we just have power and ground. Both sides are labeled. You can see power is on the outside, ground is in the middle. I'm noticing on the power wire here, I have a little extra bit of solder. So maybe I just come in here with my iron and collect it. Actually, what I think I'm going to do is put a little bit of new solder on the end of my tip here and see if that can help clean things up a little bit. Yeah. And again, you figure out what works best for you. I might actually put the connector rather than the PCB in the vise here, and then maybe hold the vise, or hold the PCB. Give that a second to cool, and then come on to the ground section. This is going to be the ground wire. This is the wire that has the most thermal mass. This is going to take a few seconds for the solder to flow. There we go. I'm now going to come in with my side cutters and trim the excess wire that's sticking above the PCB. I'm going to try and put my fingertip over the wire I'm cutting, just so that way it doesn't go flying off. And there is the blade connector soldered to the blade controller. So now I need to solder the blade controller to the LED PCB. I need to make sure that the side that has these 7 pads exposed, that the blade controller is soldered on top of that side of the LED PCB. Alignment is going to be a little bit tricky here. It's very important that these are as aligned as possible. Both PCBs have a hole in them. You can use that to help you with your alignment. What I think I'm going to try doing is taping the two sides together before I start soldering them. I want the two PCBs to be as tightly sandwiched together as possible. I don't want there to be any gap in between, because that's going to lead to putting stress on the solder joints that could cause them to eventually break. So I want to make sure that these are really nicely sandwiched together. So I'll start by just putting tape across the bottom like that. Bring this over. Make sure the blade controller PCB is facing up with the components facing up. I don't want to do it upside down like that. Try and get things somewhat aligned here. That looks pretty good. And they're held together, but there's still a little bit of wiggle room if needed. But that looks okay. These connections look like they're aligned well. The top looks like it will be aligned well. So I'm going to solder these two bottom joints first and go from there. These are ground connections. There's going to be a lot of thermal mass, so this will take a little extra time to solder together. That's one side. That's the other side. And I'm pushing down, and my fingers are warm. But I want to make sure we've got those pushed together as tightly as possible. You can see one of these wires, or one of these holes here labeled B1, I have inadvertently filled in with solder. We can fix that with some solder wick real quick while we're on the job. Cleared out the hole. And now I can remove the tape here and solder the top connections. Now I want to put something underneath the PCB here. I have these capacitors and wires hanging down. I can't just lay this flat against the work surface, so we'll bring back the tile like so. And we'll also tape the PCB down, the LED PCB down, so that way it's not moving while we're doing this. I said tape the LED PCB down and immediately went to taping the blade controller, because that's the kind of person I am. You can solder each joint individually. I'm using this big giant chisel tip here. I don't really have the finesse with it that I would with the smaller tip. So I'm just going to apply some solder and then drag it across, and we'll see what kind of a connection we get. Right now I'm just trying to get a little solder here on all the pins, or all the pads I should say. And I can come through here with my iron, drag it across these connections a couple of times. Doing so will help even out the distribution of solder. The flux will make sure that the solder sticks together well, and those look like good connections without any shorts in between them. I could also apply extra flux that we used earlier with the assembly of the blade controller to help make that a little bit easier. In fact, I'll show you what I mean. I'm just going to take my Chip Quick flux here, bring in some extra flux across all of those connections, bring in the iron and go right down the aisle. And those look like good connections. The next thing I want to do is clean up the solder joints with some isopropyl alcohol just to get rid of all the excess flux. And then I want to install everything back into the blade connector and test it out, see if the blade controller is working. Sometimes the flux will get onto the side of the PCB, and you'll go to grab the PCB and notice it's a little bit sticky on the edges there. So I'm just going to clean the edges. If I want to be really careful and make sure I have a good connection there, I can use my probes here from my multimeter. Set the multimeter to continuity mode so it makes a beep. And I want one end on the purple PCB and one on the white PCB. This will just help confirm we have good connections all the way across. So I feel pretty confident that we've got some good connections there. So now it's just time to bundle it up and see how it works. So we will grab the inner sleeve first. The one with the post sticking up goes on the bottom, and it goes through the hole in the PCB like that. At this point we can look at how the wires are going to fit, and if there's any fit issues we can deal with that. Maybe adjust how these wires are, maybe slip them, all three of them, through the capacitors. Maybe that's better cable management, I don't know, maybe not. You can do it however you want. The top sleeve goes on, and they come together nicely, nothing is in the way. Bring the foam all the way up, and notice there's a large hole on one side, a small hole on the bottom. Make sure a large hole aligns with large hole, small to small. And that should go right in like that. Good. We can now grab those guides, those silver guides. One there, and in fact I'll just put the bottom piece on right now. Like that. Now this is where the fit really starts to be an issue. How are those capacitors fitting? Because there is a groove here where the lip of the connector will fit into. Are the capacitors running into it? If they are, we might need to nudge those capacitors backwards a little bit, or maybe spread them to the sides a little bit. I have a little groove in that lip there that's going to go right here. Let's see how everything fits. There we go. Bring the wires to the middle. We don't want them going over where the screw holes are. Now we can put the top half in. A little guide goes there, and this goes on top like that. Both sides are flat. Everything is good. I'm putting my finger into this slot here and twisting a little bit just to make sure that the blade connector hasn't fallen out of position while I was putting the top on. Now we can throw the screws back on, but I'm not going to. And I have a Savvy's hilt. Yes, it's a red crystal in color only. It's been programmed white. You can see white LEDs blinking away in the window there. So here we go. I did not hear the insert noise. Alright, there we go. The hilt just, I guess, was in a weird state because I haven't used it in a while, maybe. So I guess all that's left here to do is turn off the light and ignite. And that is a nice, sharp, clear white. And we have our color picker mode. Color picker mode picked. This is a ever-changing color. Each segment having a different color. Yeah, this all looks really good. The installation of the custom blade controller was a success. We now have a functional custom blade controller inside of our Galaxy's Edge lightsaber blade. We could screw everything back together and be done with the modification. However, there are a couple of additional features that, if we choose to, we could add access to them. These are optional, and what follows is not something you are required to do in order to have a fully functional custom blade. If we look at the blade controller, you can see we have a couple of holes here labeled B1 and B0, and in the middle a third hole labeled ground. B1 and B0 are pins on the microcontroller that I have brought out to these holes. My firmware, as it stands right now, will treat these as switches. They're currently open, or off. You can turn them on by connecting B1 and or B0 to ground. In the README file on the GitHub repository, there is a section called Optional Switches, which explains these two switches and what they do. B0, when it's turned on, enables a write protect. When you turn your blade off, if you leave it off for 10 seconds or more, whatever color and animation effect you currently have selected on your blade will be written to the memory that's inside the microcontroller. By enabling write protect, you remove that save feature that happens after the blade has been turned off for 10 seconds. B1 will force the blade to behave like a stock blade. If you turn both of those switches on at the same time, then the blade will only ever behave as however the settings that are saved on the microcontroller. To access those extra features, we need to install switches. What I do to add access to these switches is I use one of these. This is a 2-position dip switch. And what I will do is I will wire one end, both pins on one end to ground, and then one pin on the other end to each to B1 and B0. And then to mount these switches, what I like to do is on the inner sleeve, the top inner sleeve here, I like to glue the switches right to it like that. And then create a hole in the outer sleeve so that you can reach in and enable those switches. So what this part of the video is going to be is me doing just that. I am going to figure out where I need to make a hole on this external piece, file it down so that it fits these switches, and then I'll go ahead and glue this in place and run wires to the PCB, and then we'll see if that all works out. So I'm going to grab a length of wire here for each of those 2 pins, B1 and B0. It doesn't have to be long. This is more than enough. This is about 18 centimeters, and I'm going to trim that even further later. So I'm not worried about the length, but I want to have a little bit more than what I need so I can trim it down to size later. I'm also going to get a black wire here for the ground. Again, I'm not being precise here, just giving myself extra wire that I can trim to fit later. Now I will expose some of the wire on each end and then twist it so that way the stranded wires stay together. Grab my solder and my wire, my iron, and just tin the tip of the wire here. The solder will hold the threads together so that when I am soldering the wire to the switches or to the PCB later, they're not going to splay out and make life difficult. And the solder will also help make the soldering job later go a little more easier. The wire I'm using, by the way, is, I think this is 28 gauge. Yeah, this is 28 gauge wire. You could use 32 gauge wire or something higher if you wanted. But the important thing here is that it's a silicone insulation, so it's very bendy, which is going to be important later because when we install this wire is going to get smushed up a little bit, and you want to make sure that it can still bend and conduct electricity. Some thicker wires, some single core wire will make life more difficult for you. What side is going to be ground? The on will connect everything, we'll turn the switch on, so I'm going to say the on side should be connected to ground. Now because both of these need to go to the black wire, I'm actually just going to bend them together. And then I'm going to tin those wires with solder, and then I will bring the black wire in and solder those to this, and we will continue. And there we go. And you can see my iron got the side of the switch there. Oh well, that's fine. Now for the other side, I'm not going to bend those wires together. They're going to be kept separate, but I do want to tin them like so. And I think I'll go with yellow first. And then blue. Give a little gentle pull on each wire just to make sure you've got a connection there. And that looks fine. I want to use a little bit of heat shrink to help strengthen those connections there. It'll also help prevent any inadvertent shorts between the exposed wires. I have my pieces of heat shrink here. I'll just slip them over. Like so. The hot air reflow station is a really good option to shrink the heat shrink tubing here. So if you have that, pull that out. If you don't, how did you get this far? That's okay. You could always use your soldering iron. But I'm going to go for the hot air reflow station. And there is the heat shrink applied and shrunk, and now we've got a good connection here, protected by some heat shrink and a lot of extra wire to make sure we're able to go from the inner sleeve to the PCB. So I know that I'm going to take the top inner sleeve and glue the switch to the edge of it like that. So I can take this and put it inside like this, and now I know where one edge of the switch is going to be, and I can mark it, which is what I'm going to do with my hobby knife here. Just scrape the inner edge here, and now we see where the switch is supposed to go, but now I need the other end of the switch. This is just so I know where to remove material. The other end, if I hold the switch in there like so, you can see there's a number inside maybe, where it says 2-2, and it looks like right right below where it says 2-2 is where the other end of the switch housing will be. And the middle, we know, is just going to be somewhere in the middle between these two. And my plan now is to create a little drill hole there. And then I'm just going to carve out the rest of the material with my hobby knife and then eventually break out a file, because my goal is to have this just fitting where it needs to go. These corners here, I don't want them poking up, otherwise it's not going to fit inside the hilt. So when I glue this, I want to glue it in such a way that the corners are just barely poking up. Just enough to match about the thickness of the plastic of this. And I'd rather have this super glued now, so that way as I am putting the finishing touches on the hole I'm going to make in here, I can adjust the size of it to match where this is when it's finally glued, instead of just hoping that they line up later and then having to make this hole bigger because my gluing is slightly off, if that makes sense. Let me get some super glue. One more thing to think about, is on going to be up or down? I want it up, I think, so I'm going to put it like that. I think I want to take my hobby knife and probably scuff up the edge here, make it more willing to accept the super glue that I'm about to put down. Probably the same for the switch as well. Just a little bit of glue. And that started bonding almost immediately. So make sure when you slide that thing into place, it is exactly where you want it to be. And there's super glue getting into the switch. That's a bad thing. That's a very bad thing. And I have nothing here to clean it up with. Shoot. Shoot. That's not good. I don't have acetone with me. Acetone would clean this up pretty quickly. I'm just going to hope the isopropyl helps. I mean, the switch seems to still work. I can move it at least, and I mean, that's the most important part here. But if I was really stuck there, I'd either get some acetone, which means a trip to the drugstore to get some nail polish remover. But I think I'm going to be okay. Yeah, I think I'm okay. Crisis narrowly averted, but that is very much on there now. And you can sort of see where it's going to go. I need to drill that hole out and then start filing things down. So I'm going to drill a pilot hole and then make the hole a little bit bigger, but not as wide as the switch is, because I'm going to assume that my hole will be slightly off. I need it to be right about there. It's such a thin plastic and chewy plastic that you could probably have cut that hole with your hobby knife anyways. And if I were to place this in like so, you can see there are the switches right there. So now I'm just gonna take this hole and square it off with my hobby knife. This is just making small nibbles into the plastic. I could have used a bigger drill. I could have used 2 drill holes. I could use maybe a Dremel. I'm just going to go slow here. I'm going to take big chunks out with the hobby knife. Once I'm close, I'm going to break out a file and start fine-tuning the hole. I'll bring you back as I progress through this. Okay, let me show you where I'm at. There is the hole. It's been squared off and enlarged a bit. And I think I may have gone a little too far to the right. You can see a little bit of daylight there. But I'm close enough now that I think I'm just going to break out some files and try and trim off the rest with a file. And I'm just going to go in and try to slowly even out the edges. This is going to take probably another 20-30 minutes. I'm just going to go slow and methodical. It'll be fine. Okay, so there is the hole, and I think we're good. Now, if I put the inner sleeve in, you can see that it fits pretty well. You notice the switches, how the stalks stick up. They are sticking up, but they're not interfering with the outer layer here, so they're not going to cause any problems when I'm inserting the blade into a hilt. I probably could have glued this a little bit higher, and the hole here is a little bit wide on the right hand side. It is what it is. I'm not going to worry about it. And nobody's going to see this because it's going to be plugged into a hilt. All that's left is to trim these wires, solder them to the blade controller, and reassemble. So now the question is, how long should these wires be? This thing is going to sit about like that, and the wires coming out here from the switch, it looks like they might interfere a little bit. We're going to have to bend them like so. See how they're lying flat like that? That should get them out of the way. Yeah, this will go in like that. These wires will go to the switch. I don't want it to be too long because if there's too much wire here, I might not have enough space in here to tuck all the wires in. The wires are going to come in like that. So I need at least that much wire, probably a little bit more just so it can hang off to the side and out of the way if I need to open this back up. So we'll just go with that. And if you're wondering how long that is, about 8 centimeters. I'm going to strip the ends here, twist the wires because it's stranded wire, and then I'll tin them and then solder them to the PCB. Actually, there's one more test I want to do. I'm going to put both switches into the on position and do a quick continuity test. Now it's a bit late for that at this point in the game. Good connection. Good connection. Turn both of those switches off. Do the same thing. Nothing. No connection. Good. Continuity checking those switches is not a bad idea, especially if you bought them from eBay, from some unknown seller. Because sometimes the quality of those switches is not the best. I've done, I don't know, 6 of these with the custom switches, and I think I had one where the switch, one of the dip switches wasn't right. Okay, those wires are tinned. Which should go where? I think I want B0 to be the inner switch and B1 to be the outer switch. So blue should go to B0, yellow should get B1. So let's solder some wires. Try and do this however you can. Yeah, we'll do one wire at a time. So I'll put the ground wire in like this, and then solder it up. Now, this is a ground plane wire, so this is going to require a lot of extra heat. Be aware of that. That looks good. Now B0. All right. And finally B1. Okay, the wires are in. I need to trim the excess off of the bottom here. I'll check my work. Okay, we are ready for the final assembly. To reassemble the blade, first take the bottom half of the inner sleeve, and we just want to bring that underneath, and it comes through the small hole here, that little post that sticks up. Like so. Now we need to put the top half on, and we need to tuck these wires in somewhere. Now what I will sometimes do is, if I have a lot of wire, I can bring it around this post here and sort of lay it down like that. But if I do that right now, if you look inside, you might notice that the yellow and blue wires are running right up against the hole there, which the top outer sleeve will be pressed down on when this is fully assembled. Now that's probably going to be fine. The yellow wire will probably be fine. But there is another way, and we're going to take a cue from how these wires used to be bundled into the sock blade, which is you have your inner sleeve top half here with the switches on it. Just give it a couple of twists like this, and it creates a little curl in the wires, and that's going to keep the wires sort of bundled up together on their own. And then you just sort of come over with the inner sleeve and try to find a way to get it down. You can see the yellow wire there is trying to poke out on either end. So grab something to tuck that in. I'm going to use my tweezers here and just sort of nudge that in. Come over on the other side and nudge that in and make sure everything closes up nice and tight like that. And now the wires are in there, and they're not in that hole where they might get damaged when we reassemble the blade. Bring the foam back up to the edge here. So slide that in like that. Grab the bottom outer sleeve here, which has the smaller guide, and then the bottom sleeve. Now we need to take this connector end here, tuck that in to where it needs to sit, the top half guide. And we should not see any gaps here. There's a little bit of a gap at the end. Is this because it's come out of place? Yes. Everything is sitting flush now. There are no gaps there. Everything looks good. So I am going to go ahead and screw this back in. Everything is screwed into place. I have both switches in the off position right now, so we should get a custom blade doing its thing without any feature enhancements yet. There we go. And the modes are still working as they should. With the blade controller assembled and installed, the optional switches installed, I am going to end this video. I have not yet covered the complete operation of the blade controller. That I've decided is going to be its own separate video, so there will be a part 5, and in part 5 I will cover how the blade controller works, how you can change colors, change different animation effects, and maybe cover a couple of gotchas, quirks of how the blade controller operates that you might want to be aware of. I know I keep asking you to hang in there, but hang in there. We've got one more video to go, and then this series will be done.